we're looking to expand these logs because they're all condensed down into one log, and we want to spread them out so that there are lots of separate logs. And this is really helpful because a lot of times we can evaluate them separately, but we can't evaluate them all together. So let's go ahead and expand these out. So the first thing I see is a quotient. I see y squared times the square root of x to the fifth over z to the third. And that's a quotient because remember, quotient is something dividing. And so I'm going to use the quotient rule. I'm going to split these two apart. So I'm going to have log of y squared root x to the fifth minus log of z to the third. And then I look and see that I have a product. So now I've got to split the product. So we're looking to split everything. So now I have log of y squared plus log of square root of x to the fifth minus log of z cubed. Okay, so now I've split it so that I have each of these are separate, and there's no more things multiplying together here. There's no more things multiplying here or dividing or anything like that. Now the last thing I need to do is the exponents. So I can just bring this exponent down, log of y, plus, now this one's a little tricky because how do I rewrite that with an exponent instead of a square root? Well, remember that the square root of x to the fifth is the same as x to the fifth to the 1/2. So I can rewrite this, instead of x to the fifth, I can rewrite this as x to the 5/2. Now I have an exponent that I can just bring down 5/2 log of x. And now I can bring down the exponent of 3 log of z, and we're done. Now this one's an ln, but really ln and log do the same thing, right? It doesn't really matter what log base that I'm using as long as I keep using that same base. So the first thing I see is a quotient, so we're going to split the quotient. So I have ln of z squared root y, that's what's on top, minus ln of x to the fifth, because that's what's on bottom. Okay, now I see a product. Again, here's a product right here. I'm going to split that, so I have ln of z squared plus ln of root y minus ln of x to the fifth. And now we can bring down our exponents. So we have 2 ln of z plus, now again, what is the exponent on the square root of y? That's the same as y to the 1/2, remember? So I can rewrite this square root of y as y to the 1/2. And now I have an exponent that I can just bring down. So that's 1/2 ln of y. And I can bring down this exponent, 5 ln of x. Now these ones are asking us to find a numerical value. So the first thing we do is we split the log all the way up until we have something until we have just log of A, just log of B, and just log of C. So we're going to have to get rid of anything multiplying together, anything dividing. We're going to have to get rid of exponents, all of that stuff. And then we'll be able to evaluate it. So let's start by splitting this up. So I see a quotient. So this is log of the cube root of a squared z to the fourth minus log of b squared. Then I see that I have the cube root of a squared z to the fourth. So let's go ahead and get rid of that cube root altogether. So remember that the cube root of a squared z to the fourth really means a squared z to the fourth to the 1/3. Oh, I said 1/3 and wrote 1/2. 1/3. Okay, so this is to the 1/3. So that exponent, that 1/3, applies to everything inside. So I end up with a to the 2/3, z to the 4/3. Okay, so you remember those exponent rules. So really, the cube root of a squared z to the fourth, everywhere I see that, I can just switch it out. So I'm going to switch this out with a to the 2/3, z to the 4/3. Okay, now I have a product of two different things, so I can just split that apart. So we're going to have log of a to the 2/3 plus log of z to the 4/3 minus log of b squared. Now remember, we're just trying to get this down so that there's like just log of something, right? And right now I have log of a equals that, but this is log of a to the 2/3, so we need to get rid of that exponent, so we're going to bring the 2/3 down. So we have 2/3 log of a plus 4/3 log of z minus 2 log of b. Oop, b. Okay, so now I have all of this, and I can now just start substituting in. So everywhere that I have log of a, I'm going to put in a -6. So I'm going to have 2/3 times -6 plus 4/3. Let's see, log of, oh, I have a z and a c. Okay, let's just, let's pretend that this was a z. I'll switch that in your notes, but okay, log of z, I don't know why that was. Actually, I'll keep that c, and then I will switch this one here. I'll switch this. This is, instead of log of z, this is log of c. Okay, so log of c. So log of c was -15. Okay, so -15, so that's -15 there. And then minus 2 times log of b, and log of b is -7. So that's -7 right there. So now we're just going to multiply all this out and figure out what it is. So 2/3 times -6 would be -12/3, which is -4. Okay, and then -4/3 times -15. The 3's are going to cancel out, and we're just going to have 4 times 5, which is -20. And then that's going to be plus 14. So we're going to have -24 plus 14, which is -10. Whew, let's try one more. Okay, so log of a to the 4th, b to the 4th, square root of, over square root of c cubed. Whew, that's a mouthful. All right, so let's start with expanding this log. So we're going to use the quotient rule to say that this is log of a to the 4th, b to the 4th, minus log of the square root of c cubed. And we know we're not going to want to keep that square root, so let's just get rid of it now. So we have log of a to the 4th, b to the 4th, minus log of c to the 3/2, because remember, the square root is just the same as raising it to the 1/2 power. Now we're going to use the product rule to split those two logs apart. So this is log a to the 4th plus log b to the 4th minus log c to the 3/2. Then we're going to use the power property to bring that 4 down. So we have 4 log a plus 4 log b minus 3/2. That should be c. Log c. Okay, now we're all the way down to where we can start plugging things in. Log a equals -2, so we have 4 times -2 plus 4 times log b, which is 5, minus 3/2 times log c, which is -6. Okay, so we have -8 plus 20, and then that's plus 9. Okay, so we have 29 minus 8, which is 21.